Okay, Calculus 30, review and preview to Chapter 5. Okay, we're going to do Chapter 5, but there's a few things from pre-calculus that you need to remember. So, you may need to watch this video, you may not, but what we're going to review are a few basic things like intercepts. Okay, what are intercepts? If we have a graph, the x-intercept is the value for x that the graph intercepts. Okay, and the y-intercept is the value on the graph that intercepts to the y-axis. So, if we just draw a quick x and y axis, and here is our function, this has a y-intercept right here, right? That's the y-intercept. Where's the x-intercept here? None. Oh, there is none. No, there isn't right here. But what if I go down like this now? So, whoops, black. So now I have an x-intercept right here. Okay? If you're given an equation, so let's get rid of this. If you're given an equation, how do you? No, it's okay. You can write it down. If you're given an equation like y equals negative 2x plus 10, and we know that this is a what? A line, a quadratic, cubic function. What is this? It's linear. Good. So this is a line. Whoa, yellow. And do you know what the y-intercept is in this? Just by looking at the equation. It's 10, right? Because the b value is... Now, how we know that? Because this is y equals mx plus b. But how can we mathematically determine the y-intercept? Yeah, okay. You guys remember it. If you let x equal 0, right? Let it equal 0, then you solve for y equals 10. You solve for your y-intercept. How do I find my x-intercept, though? That's my question to you. Really difficult. Sorry? Well, make it all equal 0. Yeah, more specifically, you want to set y equal to 0 to find the x-intercept, right? Set y equal to 0, find the x-intercept. So that's 0 equals negative 2x plus 10. 2x equals 10, x equals 5. So at x equals 5, we have an intercept. At y equals 10, we have an intercept. And of course, we connect that with a line. Another brilliant yellow line there. And that's our line. Boom, got it. Okay? Intercept there, intercept there. Okay? Intercepts, really easy, right? This is like, so easy. Okay, let's get back to our book. If we're asked to find the intercepts here, which you will be, okay, let x equal 0, solve for y. Let y equal 0, solve for x. If you let y equals 0 and you have to solve for x here for something like this, notice that this is a quadratic. You're going to want to try and factor, use the zero product principle. If you can't factor and use a zero product principle, what's the formula that you can use to find out the roots? X equals negative b plus or minus root b squared minus 4ac all over 2a. Right? There's a video on that quadratic formula. You should look it up.
Can we make a music video to that?
Follow the link below. Yeah, I'll have to remember to do that. Anyways, that's quadratic formula. Whoa. Okay. What about this here? What do you do if you have to find, if you let y equals 0, what do you do there?
Take y, x out.
Yeah, you could take an x out, then it's easier. If you have x to the 4th or you have a big polynomial, you may have to do synthetic division like we did this last chapter. Okay, moving on. Symmetry. Symmetry. Okay? This is something you may or may not remember from pre-calculus. But symmetry. A function is even if. You should write this down. Okay? A function is even. So we call this an even function if f of negative x is the same as f of positive x. Wow, what happened there? That is really weird. Yes, if f of negative x equals f of positive x. And something really weird happened with this. Look at this. There we go. Somewhere around here is normal. All right. So, for example, an even function, y equals x squared. That's an even function. Why? Because if you substitute, let's say we substituted negative 1 in there. So that's negative 1 squared. That equals 1. And if I substituted positive 1 in there, that's positive 1 squared. That equals positive 1. Because f of negative 1 and f of positive 1 are the same value, this is an even function. Now, what does even function have to do with the symmetry? Where is the symmetry in y equals x squared? So here's y equals x squared, roughly. Where does symmetry exist here? Sorry? On the y-axis. Okay, very good. So there is a vertical line of symmetry through the vertex of a parabola, always. So if we're talking about an even function, there is a vertical line of symmetry somewhere. Got it? Okay. So even if it's y equals x to the fourth or whatever. Now, what about y equals okay? What about y equals x squared? Well, let's do x minus 2 squared, all squared, and then let's add a 3. Why not? Okay, what about this one? Is this an even function technically? We talked about symmetry, vertical line of symmetry through the vertex. Is that the complete definition for? Is that the symmetry we're talking about? Okay, so let's see. If I do f of, well, let's just do f of 1. So that's 1 minus 2 squared plus 3, which gives us what? Negative 1 squared is positive 1, that's 4. What about f of negative 1? Well, that's going to be what? Negative 1 minus 2 squared plus 3, what's this? Wait a minute. That's negative 3 squared is 9 plus 3 is 12. Oh my. Oh my. So is it a vertical line through the vertex? Is that what we're talking about? Or is the symmetry we're talking about here something more than that? It's obviously more than that. So look in your book now. See if you can see right there. See in your book. And here's the book up here. For those of you that don't have a book, here's the book. What does it say right underneath this symmetry thing? Whoa. If a function is even if it is unchanged when x is replaced with negative x. Awesome. The graph of an even function is what? Finish that sentence for me.
Symmetrical about the y-axis.
Ah, okay. So not just a vertical line of symmetry. No. If we're talking about symmetry, if we're talking about a truly even function, it's actually a line of symmetry that is the y-axis. So that's why this one, what does this one look like? This graph actually looks something like, what is it? Okay, 2 to the right and 3 up. So it actually looks something like this. This is not an even function, no, because as we were just saying here that this y equals, or the y-axis there, x equals 0. It is not symmetrical about the y-axis. There is a line of symmetry, but for the purposes of this chapter, an even function gives us a line of symmetry on the x-axis. So this is even up here, this is not even. Even though it has an even degree, it's not an even function. Okay? So, going back there to the book, where's my cursor? Okay, so the graph of an even function is symmetric about the y-axis. Okay, so you need to write that down. An even function. Symmetric about the y-axis. So that's an even function right there, because if you draw a vertical line through the y-axis, it's symmetrical. Exact same on both sides. Mirror image. Okay, odd function. Well, let's talk about an odd function. This is an odd function here. And I'll use a different clipper there. Nope. An odd function is where f of negative x equals, oh my, something is afoot. What is going on here? Let me just see. View, 100%. Okay. Weirdo. All right. Even function. Odd function. What? Boo. Boo, boo. Okay. Boo. All right. This is a media timeout here. Okay. We'll be back after these messages. Okay. This should work, everyone. This is going to work now. Odd function. Let's plop her down there in the notes. Beauty. Odd function. Okay. F of negative x equals negative f of x. You see the slight difference here? All right, so y equals x cubed. Let's test that one out. F of 1 is 1 cubed is 1. F of negative 1 is negative 1 cubed, that is negative 1. So is this an odd function?
Oh, absolutely.
Well, f of positive 1 is positive 1. F of negative 1 is the opposite. So yes, this is an odd function. So if we draw really quickly this graph right here, this is what y equals x cubed roughly looks like. And so where is there symmetry there? It's symmetric about the, says right here, symmetric about the origin. Okay? If something is symmetric about the origin, that is a one single point, that means it has some rotational symmetry. Rotational. Okay? Now let's see if I can do it. I don't think I can actually do this. Can I? No, I can't. I was going to turn it around for you. But if you envision this graph gets turned around, so you have kind of this happening when you turn it 90 degrees, and then you have this happening when you turn it again. It maps onto itself. See that? It's like a pinwheel. You know one of those pinwheels, the thing that wind blows and spins, whatever. Okay? All right, symmetric about the origin. What else is symmetric about the origin? What would be some kind of odd degree? Well, if you had something like, oh, say this. Oh boy, this is going to be tough to draw actually. So something like this. Well, it's could be a cubic function. Yeah, could be. But you see how it's symmetrical about the origin? It has rotational symmetry. If you were just to flip that around, it would map right onto itself if it's turned. Yeah, I feel like I want to grab. All right, so here's a little video found here. This is an even function. Okay, it's even because look at as we move positive x, negative x. You see how the values are always the same? That's cool. If you ask me, that is cool. What about an odd function? Okay, as x moves, where is it? Oh, positive x, negative x. Positive f of x, negative f of x. See that? Always opposite. And if we could turn this one around, spin it, you know, you could spin it halfway around, 180 degrees, and it would map exactly onto itself. So when you have symmetric about a point, it has rotational symmetry. You see how I did that? Rotational. If it's an even function, it has a line of symmetry, so there's some kind of, you know, symmetry there. Oh, okay. Kudos to all those people. Okay. Got it? Yay? Nay? All right. So you can always check, right? You can always plug x in to the function, plug negative x into the function. Take a look. What's this one? What's this one? This is not going to be this graph. This is going to be... Okay, go ahead. Take a minute. Tell me if that is odd, even, or neither. Odd, even, or neither. Can you concentrate? Odd, even, or neither. Boom, 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 boom. Even, neither. Odd, even, and neither. Dum, dum, dum. This is what you're testing on right here. Just pick a value of x, like 1 and negative 1, like I was doing with the other ones. So what do you get? It's neither? Okay. So what's f of 1 here? That's 2 minus 5 is negative 3 plus 1. Negative 2. What about f of negative 1?
8. 8?
So those the same? No. Are they the same number of opposite sign? No. So neither is your answer. Okay?
Mr. MathWell.
You are very welcome. So welcome. What?
She said, you are very, very welcome.
You are very, very welcome. Like that? I don't know why we do that. Okay, where's exercise 1? Okay, I'm going to show you the questions here. If I can. That is weird. Oh, here they are. Sorry. Okay, exercise 1. There we go. Number 1. Exercise number 2 is down here. There's 1. And there's 2. English. English.